OK，我们开始啊。So 今天我会讲 the last part of electricity, internal resistance, and hopefully we have time we finish up the power and energy. OK， 之前的功课有问题跟我讲啊，讲上次我 send 给你们的，教你们做那个 combined circuit 的那个。Make sure the combined circuit you grasp the concept and then only you move on. OK, internal resistance 还有 EMF 啊。首先我要先讲它的分别在哪里 ，EMF 跟 voltage 的分别在哪里 ？OK, so EMF stands for electromotive force, and it is actually very, very similar to potential difference, but they are not the same. OK, EMF 就是真正 battery supply 的 energy。OK， 所以如果你看 voltage 哦 ，voltage 的 general equation 是 W over Q， 它是 work done to drive 1 coulomb of charge. Work done to drive 1 coulomb of charge around the circuit. Okay, so 1 coulomb of charge, 一个 electron 是有差不多 1.6 times 10 negative 19, right? 1.6 times 10 negative 19 charge. This is for 1 electron. So 1 coulomb, you have many, many electrons. So potential difference 就是 the energy you need to push all 1 coulomb of electrons around the circuit. And that is measured in volt. So if I say that the battery has 3 volt, it means that it has 3 joules for every 1 coulomb. It supplies 3 joules for every 1 coulomb. This is the actual, the real EMF, the real voltage of the battery. Okay, so any voltage that is shown on the battery, if I said that the battery is 3 volt, then the 3 volt is the EMF, is the electromotive force. Now, then potential difference 是什么呢？就是如果你放这个 battery 在一个 circuit 里面哦，你会发现到你的那个 battery 的 voltage 其实不是3 volt。OK，by right 它应该是3的，可是当你一 connect 进那个 circuit 时，它 show 的 voltage 不会是3，它会比较小一点。OK，so let's say like this. This is the battery. Now, if you connect in the circuit, so you have resistor here. It has a switch here. Let's say this switch is open. Okay, so you have a resistor, ammeter, and then you have a voltmeter here. Now, 如果我 connect 我的 voltmeter around 我的 battery 啊，我是在 measure voltage across the battery, right? So this voltage, if the battery is 3 volt, then this voltage will show 3 volt. Notice that the circuit is not closed. This is open circuit. Okay, in other words, in open circuit, the voltage that you measure across the battery is actually showing you the EMF. It is the true voltage provided by the battery. There is no current flowing in this circuit because the switch is open. Now, when you close the switch, what happened? So the moment you close the switch, you will see that the voltage across the battery will drop a bit. Same setting, same setup, the V here. So when you connect, close the circuit, then this value here, maybe it shows 2.7 volt. Why? There is a potential drop here. Okay, so we said that the potential drop is how much? The potential drop is equals to 0.3 volt. So why is there a potential drop? This potential drop is actually due to what we call is the internal resistance. 那个 battery 里面的那个 electrolyte 本身它自己也是有 resistance 的，我们叫它 internal resistance。所以当你一关那个 circuit 的时候 ，current 一开始 flow 从那个 battery 走出来，然后又 flow 进去时， 当它 flow 在那个 battery 里面的时候，它会经过一个 internal resistance。那个 internal resistance 其实是 from 它的 electrolyte。OK，the electrolyte of the battery is the thing that produces the charges. Okay, the electrolyte. Okay, so as a result, you get this potential drop. So what is the difference between EMF and potential difference? I can also say this as the potential difference, right? I can also say this as the potential difference because in the end, I'm measuring the voltage. I'm measuring the potential difference. The difference is here. EMF is the potential difference across battery in an open circuit. This one you need to remember. Okay, again, EMF 就是 potential difference across battery in an open circuit. Because in an open circuit, no current is flowing. So if no current is flowing, then there will be no voltage drop because the current cannot flow inside the internal resistance. No current, no voltage drop. So the voltage remain as maximum 3 volt. Okay, maximum 3 volt. On the right, this circuit, you got current flowing. So current flowing in the external circuit, and then it enters the battery. Current enters the battery. If I zoom in the battery structure, it looks like this. This is how we represent it. Okay, so this is the battery. And then we draw something like this. Okay, battery. And then in the resistance like this. I box this area. This area shows the body of the battery. So inside you have a resistor here. This is, we call it small r, and this is the EMF. This is the EMF here. Okay, so EMF and R here. So in a closed circuit, when there's current flow, current passes through the internal resistance. So that's why you get a drop here. Now, here we want to form an equation for the internal resistance. So 我可以讲EMF 是 total voltage， 它的 actual voltage 是吗？然后 potential difference across the battery, we said it is the terminal potential difference. This is the terminal potential difference. OK， 所以你之前我们做的全部 calculation 呢，你的 V 等于 IR 是 EMF 还是 terminal potential difference? You have to be very clear. All the calculations that we have done before for all the circuit parallel and series, we are actually calculating the terminal potential difference. Why? Why are we calculating terminal? Because in all the circuit previously, they are all closed circuit, right? In the calculation, there are always current flowing. So every circuit is a closed circuit. So since it is a closed circuit, then the voltage shown on the voltmeter is actually the terminal potential difference. It is not the real voltage of the battery. It is slightly below the real voltage of the battery. Okay, so I can say that the EMF of the battery is equals to the terminal potential difference, V, plus the voltage drop. Is like this one. It's like the 3 volt equals to 2.7 volt plus the drop of 0.3 volt. Okay, so here I get an expression, and then I expand this one. I can say that the EMF is equals to V. 我们平时算是怎样算 V 等于 IR 对吗？ Terminal potential difference V 等于 IR， 所以这个我们写成 IR 再加 voltage drop 也是 IR， 可是我们用小 r 来 represent 我们的 internal resistance 在里面。So V equals to I， 然后小 r 加 VI 小 r. This equation that you need to remember. I can also factorize out the I. So I get I R plus R here. Okay. So equation 1, equation 2. Now 从这里哦，我们要怎样知道 battery 的 EMF 是多少呢？如果每次我放在那个 circuit 里面哦，我一开电哦，它 show 的 voltage 都是 terminal potential 的话，这样我要知道它真正的 EMF 是多少。OK， 这样子我们要 set up 一个 experiment 来找它的 EMF。OK， 怎样找它的 EMF？ 我们首先 we set up our experiments like this. Okay, we take a circuit and then we put a rheostat and a resistor, and we need to have a switch, ammeter, 然后最后我要 connect 我的 voltmeter。voltmeter connect 在哪里？记得 voltmeter 我们 connect 在 battery。平时你的 voltmeter connect 在那个 resistor 嘛，对不对？这次我们 connect 在 battery， 因为我们要知道那个 battery 的 EMF。所以我的 setup 是这样子。Now rheostat 的功能是什么？ rheostat 是用来它的 resistance 可以改变的，对吗？我可以 increase 它的 resistance， 我可以 decrease 它的 resistance， 所以我可以 control 那个 current。我增加它的 resistance， current 就减少在那个 circuit。我减少它的 resistance， current 就会增加。So I can control the current by controlling the resistance here. For 这个 fixed resistor 呢，为什么 fixed resistor 要有在这一边？因为哦，如果没有那个 fixed resistor 的话是，这样你有可能会拿到 short circuit。short circuit 是什么？记得吗？ short circuit 是当你的 circuit 里面没有 resistance， 所以那个 current 会太大 ，current flowing in the circuit is very big. It can cause fire and overheating. So without this fixed resistor, imagine if you don't have the fixed resistor, then when you decrease the resistance from the rheostat, when you decrease the resistance, the overall resistance will become so small, then the current will increase and it will become a short circuit. So you need at the minimum, maybe you attach a 2 ohm resistor here. So no matter how you decrease the rheostat resistance, there is still a base there. There is still a base of 2 ohm in the circuit. So even though you decrease all the way down to no resistance, okay, still you have a 2 ohm in the circuit. So this will prevent the short circuit. Okay, so the fixed resistor here is to prevent short circuit. Okay, so now 我一定要有了 rheostat， 因为我要拿 different values of current 嘛，对不对？我的 manipulated variable 就是我的 current。I want to get different values of current. Maybe I want to get 1A, okay, 2A, 3A, like this. And then my responding variable would be, I want to calculate the voltage. When I get the current, then I read the voltmeter, I get the current, I read the voltmeter, I record every reading. And then I can plot a graph, okay? So this graph will look like this. VI graph, VI graph. So VI graph, now 在这里哦，我们的线其实是你会看到哦，如果你 plot 那个 reading 时，你会看到你的线是 sloping downward 的，是这样子的。OK， 当你 increase current 的时候，你的 terminal potential difference 会减少。Okay, let's say this is I1. Okay, then it gives you value of V1. I2. Increase current, V2 is smaller. Okay, then you go on, you keep on increasing the current, the voltage decrease. Why? Because when you increase current, the voltage drop will also increase. So looking from the formula here, when the voltage drop increase, then the terminal potential difference will decrease. From the graph, you're actually measuring this one. You're not measuring the voltage drop. You're measuring the terminal potential difference. This graph, the V in the y-axis, is the reading here, is the terminal potential difference. So when the voltage drop increases because of the internal resistance, and because of larger current flowing inside the battery, the voltage drop will be bigger, and then your terminal potential difference will decrease. That's why you get a sloping down graph like this. Usually, VI graph is sloping up one. If you look at normal VI graph, this is the VI graph across resistor, not battery. Okay, across the resistor. So it should be straight line like this. Ohm's law 嘛是 V 等于 IR。你的 resistance 是 fixed， 然后它就 directly proportional. Okay, this is the voltage across the resistor. When you increase current, the voltage will increase. But this one is the only graph, the only VI graph that is sloping downward. That is the internal resistance graph. Remember this, okay? Whenever you see VI graph like sloping down, then you know this is internal resistance, okay? This is the EMF graph, okay? And the difference between these two, this is measuring the resistor voltage. This one, we are measuring the cell, the battery voltage, okay? The battery here. So you get this graph. Now, you will see that this graph, 你拿不到那个 y-axis， 意思说你 plot 的时候是你不知道 current 等于0的时候，因为你不能拿到 current 等于0在这边嘛 ，OK， 除非你 open 你的 circuit 啦 ，OK。So what happened is that you will extend this graph. I want to extrapolate this graph to the back, all the way to the back. And this one also I extrapolate. Then I see where it touches the y-axis. So it touches the y-axis at here. Then I will say this is the EMF. Okay, you see, why is this EMF? Because the current is 0 here. There is no current flowing in the circuit. So we take the corresponding voltage value that is equal to the EMF. Okay, so this graph is terminal potential difference against current, right? Against current. But how come we can get EMF from here? So that's why you have to understand EMF is actually potential difference, just that the current flowing in the circuit is 0. In this case, it will show you the EMF of the battery, the real voltage of the battery. Okay, now 可能你问，为什么我不要直接开那个 circuit， 然后我直接看那个 voltage reading， 我直接拿那个 EMF， 为什么要这样麻烦，还要画 graph， 还要找每一个 value， 还要 plot 那个线，还要 extrapolate。我可以直接开那个 circuit so that no current is flowing in the circuit， 然后我直接拿那个 reading of the voltage， 那个就是 EMF 了嘛。OK， 你可以这样子做，没有问题。可是问题是，如果你 plot graph 的话，是你会拿到比较 accurate 的 value， 比较 consistent 的 value。OK， 因为你有不只是一个 reading， 你有几个 reading 来帮你拿那个 graph. So the value that you get from the graph here is more accurate, is more consistent. Okay, so but technically speaking, if you just measure like this, you will open the circuit, you just take the reading, that is EMF. Yes, that is EMF. Okay, that is also EMF. Okay, so now looking at this graph, okay, let me go to the next page. Let me go to the next page. Now looking at this graph and the equation E, 这个 graph 是这样子，对不对？ It's not that steep, like that. Okay, so PD against I extend. This is EMF, and because this is current is equal to 0, right? So this is EMF. How about all this value? The value here, V1, V2, V3. They are not EMF. They are the potential difference. Okay, so from our equation, E equals to IR plus IR. 我 arrange 它，这个是我的 terminal potential difference， 所以我 arrange 它这样子 ，IR 等于减 IR 加1 ，OK， 所以这个 IR 我把它 combine 成 V 先，等于减 IR 加1，这个就是我的 terminal potential difference 对吗 ？OK， 所以等于这个，那我 compare 咯 ，Y 等于 mx 加 c，Y 等于 mx 加 c，OK， 这个我可以再调位这个两个减 r， 然后 i。Okay, then you can compare. Your y-axis is the v, and your x-axis is the i. Your y-intercept 也就是它的 y-axis touch the band 是你的 EMF. That's why this is the EMF. And your gradient, you can see there's a negative here. That's why the graph is sloping down. So negative r. So the gradient here, if you take the gradient, what do you get? You get the internal resistance. So that is how we find the internal resistance and find the EMF of the battery. Okay, now example. Okay, one example of calculation. Okay, so here we have a circuit. A battery is connected in series with the 10 ohm resistor. This is 10 ohm. And then the potential difference across the resistor is measured 2.5. Okay, 这里是 2.5 volt. Now, if the internal resistance of the battery is given as 2 ohm, so if this is 2 ohm, then what is the EMF of the battery? Okay, then we use the formula to find it. Okay, first we want to find what is the current flowing in the circuit. Okay, 找 current 先，讲找 current， 用我们之前做的那种 calculation V 等于 IR， 你要找 total current， 你要 effective resistance， 你要 total voltage. Okay, so voltage 是等于给 IT 等于 VT over R effective. VT 就是2.5咯，2.5，因为你看这个 circuit 哦，它只是一个 resistor 罢了嘛 ，so 那个 resistor 的 voltage 也就是那个 battery 的 voltage。你看我这个可以这样子画的哦，我可以这样子画，我单单画那个 battery， 然后我画10 ohm。I can also draw it like this. If I don't want to show the battery internal resistance, this is normally what you see, right? Previously, like this, V here. So if this V is 2.5 volt, it means that this battery here is also 2.5 volt. So across this battery here and here, 2.5. Okay, so it's the same thing as this. So total voltage 就是2.5除以 effective resistance。好，小心这个 effective resistance 啊，我们不用去加那个 internal resistance， 因为平时你找 effective resistance， 你都是没有理 internal resistance 的嘛，对不对？所以你看你的这个右边的这 circuit 只是10罢了。So 10, 2.5 divided by 10, so you get 0.25 ampere。0.25 ampere， OK， 现在我知道 current 了，我用我的 E 等于 IR R 加 R。Okay, so E equals to 0.25。This R is the effective resistance, so 10 plus the internal resistance of 2, so 0.25 into 12 等于3.0 volt. And this is my EMF. So 你可以看哦，我一 connect 我的 circuit， 我拿到的 voltage 只是 2.5 罢了，只是 2.5 罢了。我真正的 voltage 其实是3，所以它的 drop 是多少 ？The V drop due to the internal resistance is 0.5 volt. Okay, 0.5 volt. 然后你可以调转哦，你看 V drop 也就是等于 IR 嘛，对不对？可是你的 R 是 internal resistance，I 你也是知道了吗？0.25。So V drop 是0.5，你也是可以调转的把你找那个 internal resistance。Okay. Okay, now this is for so far that's it for the internal resistance. And the next part I want to talk about is the power and energy. Power and energy. So this one, we put this aside. I'll go to the next page. Okay, power and energy 其实不多，只是 calculation, mainly calculation only. Okay, so it's very simple actually. Okay, the thing is you want to remember this one. V equals to IR. This is the general Ohm's law, right? Ohm's law. And then we have power equals to IV. Remember this equation here. Power is equals to current times into voltage. And then if you remember this one, then you can derive all of the rest. How? Okay, you see. V equals to IR. 把它放进去这边，我拿到什么 IR. So I square R. Power. This is the first one. No, this is the first. This is the second. Okay. And then I can also substitute I inside. Okay. So V 等于 IR. I 是等于 V 除以 R. 我把这个 I 放进去这里。我又拿到一个 equation. P 等于 V over R. V. That's V square over R. Number 3. Equation number 3. So you have total of 3 equations for power. Okay. Now for energy 呢 ？Energy 也是一样的，你也是可以 derive 出来。OK, power 跟 energy 的 relationship 是什么 ？Power 等于 energy 除以时间。So energy 等于 power time. This is the first equation for energy. 接下来把这种放进去 ，OK， E 等于你的 equation 2， 这个 OK 放 equation 1先 ，P 等于 IV 对吗？所以 E 等于 IVT。Number 2， okay, E 等于 IVT，and then what do you do next? You can also sub this one inside, right? I square RT. So E equals to P 是 I square R 再乘 T. That is your number 3. And the last one, E 等于 V square over R 乘以 T. The last one. Okay, so total all for power and energy, all the formula is here already. Now, if you ask which one do I use, depending on the question, if the question does not give you resistance, it only gives you voltage and current and time, then you most probably you're going to use this, the second one, this one, IV T without resistance. Okay, so for example, a current of 5 ampere flows through the electric heater when it is connected to 240 volt. How much heat is released after 2 minutes? How much heat released after 2 minutes? Okay, you connect the heater to a 240 volt. It's like the home socket. You connect the heater, you turn on, and there's a current of 5 ampere flowing, and then you allow it to operate for 2 minutes. What is the total energy? Okay, which one do we use? Energy equals to here given current, given voltage, given time. So the first one, power not given, we can skip it. So we use the second one lah, IVT. Okay, 只是要 make sure 你放在 SI unit 呢，5 ampere 乘以240乘以2 minute 乘60 ，change into second. Okay, change into second. So we get 144,000 joule. 144,000 joule. Okay, nothing much for the power and the energy. The rest is just calculation. Okay, using the formula, using the calculation. So you need to practice more on the calculation for this part. Okay, for this part. Now, there's one thing I want to say also about the Ohm's law. About the Ohm's law. Okay, give me a few seconds. Okay, next part, I want to talk about the VI graph. And wait, the VI graph for different components. Okay, VI graph for different components. Okay, 这里哦 now graph 也是很重要，因为 electricity 里面哦，很常你会遇到 graph 的问题。Okay, most typical graph is the VI graph. Okay, the VI graph, you got two types. VI and IV. 两个都是你会拿到 straight line. For ohmic conductor. Okay, what is ohmic conductor? Ohmic conductor 是那种 obey Ohm's law 的 conductor， 就像你普通你的那种 resistor 啊 ，fixed resistor， 它们都是 ohmic 的。Okay, all this you put the circuit like this, right? Resistor. Normal resistor made of normal resistor, they are ohmic. Okay, the fixed resistors. If you connect a voltmeter here, and you got ammeter, you will get the graph like this. Okay, doesn't matter you plot VI or IV, you get the same graph sloping here. Okay, now from the equation V equals to IR, why it looks like this? Because the R is constant, the resistance is fixed for an ohmic conductor, this one. Okay, so the resistance is constant, so I can say that V against I, Y equals to mx plus C, right? So this is 0. If my y-axis is V, my x-axis is I, then my gradient is R. 这里跟这里我拿它的 gradient， 这个就是它的 resistance。谁的 resistance？ 这一个 component 的 resistance。The one that at the component which I measure the voltage. Okay, it is the resistance of that component. How about the IV graph? The IV graph, it would be the reciprocal of resistance. So the gradient M would be equals to the reciprocal of the gradient. Terbalik. Okay, 调转。所以你要很注意，就是你要看你的 graph 是什么 graph 哦。如果你的 graph 是 IV graph，然后你拿它的 gradient，就是你直接等于 resistance。That is not correct. You have to invert that. Okay, 1 over R is the gradient for the IV graph. Okay, so now for ohmic conductor 呢，它的 temperature, sorry, not temperature, 它的 resistance 是 fixed, right? Provided 你要有 same temperature. The surrounding temperature must not increase, must be the same. Why? Because 如果你的 surrounding temperature increase 的话，它会影响那个 resistor 的 resistance， 它会增加它的 resistance。OK， 因为如果你把它想成，其实 resistance 就是那种 charge 哦。OK， 这个是 the internal structure. You have many atoms, right? Let's say this is the wire, okay, the copper wire. So the charge is moving in the wire. Electron moving in the wire. They travel at high speed. Now, when they hit the atom, they will slow down. Okay, the more atom there is, the slower that they will travel because of the collision. So the resistance really comes from the collision with the atom. If the temperature is high, what happens? The atom, they vibrate faster. Okay, so when they vibrate faster, then there will be more collision. What happened? More collision mean more resistance lah. More collision, more resistance, and thus the resistance will increase. So in general, when temperature increases, resistance will increase because more collision here. So for this fixed resistor, we have to make sure the surrounding temperature is constant. If you want to get this graph, if the temperature surrounding is changing, then you will not get a straight line graph because it no longer shows Ohm's law characteristic. It no longer obeys Ohm's law. Okay, so we are going to stop here for a while, and I'm going to create a new link, and we continue there.